Here in this question, we need to write balanced chemical equation for oxidation of chromium from chromium hydroxide to chromate, or reduction of iodine from iodate to iodide. How can we write a balanced chemical equation for this one? We can see now. For that one, first of all, you should write oxidation numbers for elements present in the reaction. It will get plus 3 oxidation state, iodine gets plus 5 oxidation state after calculating, then chromium gets plus 6 in a chromate ion. So from iodate to iodide, by taking 6 electrons, it will become I minus, so that it is the reduction half reaction. In the same way, by losing 3 electrons from chromium hydroxide to chromate, it will become chromium plus 6, so that it is the oxidation half reaction. So after identification which one is oxidation half and which one is reduction half reaction, you should need to write separately those two half reactions. So here it is the oxidation half reaction, and there I am going to write reduction half reaction. So what is the oxidation half reaction? Chromium hydroxide converted into chromate CrO4 2 minus ion. Then I minus, that means IO3 minus iodate converted into iodide. IO3 minus converted into I minus. This is the first step. After that, we should balance a number of oxygen atoms. For this one, you need to identify first of all the reaction is going to takes place in which medium. Is it basic medium or acidic medium? Here it is going to takes place in a basic medium, because COH minus I already indicated it. So in basic medium, for balancing oxygen's number, we should add OH minus ions. For balancing hydrogen's number, we should add water molecules. So here left side of the oxidation half reaction having 3 oxygens, right side of the oxidation half reaction having 4 oxygens. So for balancing oxygens number, I just add 1 OH minus ion to the left side of the oxidation half reaction, CrO4 2 minus. Then you can see here, after that we should write, we need to balance a hydrogen's number. So here CrOH taken thrice plus OH minus CrO4 2 minus. C, left side of the oxidation reaction having 4 hydrogens, so that if I write 2 water molecules, that will equal to 4 hydrogens, but oxygen's number will be vary. So by hit and trial method, if you get 2 or 3 more steps, so that avoiding 2 or more steps, I am going to write directly, see, 4 water molecules to the right side of the oxidation half reaction, so that you can add in that step only, because by adding 4 water molecules, oxygen numbers will be vary and hydrogen's number will be vary for the left side of the oxidation half reaction. So that if you add see 8 hydrogens, here 8 oxygens, here 4 oxygens and 4 hydrogens, so that if you add 4 OH minus ions, then you will get equal number of oxygens and hydrogens for both sides of the oxidation half reaction. Okay. Coming to this side, here also you can balance oxygen's number by adding OH minus ions to the right side of the reduction half reaction. So see, 3 hydroxide ions I'm going to add. For balancing H plus ions, left side of this reaction, 3 water molecules you should add. So again here hydrogen's number and oxygen's number will be vary. Here see, 3 oxygens, 3 oxygens, 6, 6 hydrogens. So that 3 more OH minus ions you should need to add for balancing the oxygen's number. So then already 3 oxygen hydroxide ions are there. So that if I add 3 more, then it will become 6 OH minus ions. So now it is a balanced reaction for in the view of oxygens and hydrogens number. See, 6 oxygens, 6 oxygens, 6 hydrogens and 6 hydrogens. So now coming to the add electrons to the half reactions, either left side or right side. See, um, chromium plus 3 converts into chromium plus 6, so that it will lose 3 electrons, then it will become plus 3 to plus 6. So you should write, or you should add 3 electrons right side of the oxidation half reaction, because by losing 3 electrons it will become plus 3 to plus 6. In the same way, here see, by gaining 6 electrons, iodate converted into iodide. So you should add left side of the oxidation reduction half reaction 6 electrons. The remaining will be same. See, so after this step you should need to equalize the electrons number for both oxidation half reaction and reduction half reaction, so that here no need to multiply 3 to the reduction half reaction, 6 to the oxidation half reaction. You just equalize by multiplying oxidation half reaction with 2. So you will equalize the electrons number. See, here it is the 2. See, this is the 2. So I'm going to multiply the complete oxidation half reaction with 2. See, 2 CrOH taken thrice plus 2 5s are 10 hydroxide ions plus not plus gives rise to 2 chromate ions plus 8 water molecules plus 6 electrons. This is the oxidation half reaction. So oxidation half reaction, then you can write reduction half reaction down to this oxidation half reaction. What is the reduction half reaction? IO3 minus plus 3 water molecules will give rise to here see, not directly 6 electrons you should add, then I minus plus 6 OH minus ions. So now here also you should cancel out the common species which are present in the both reactions. 6 electrons cancel out, and 3 water molecules, there 8, so that 5 water molecules are the remaining. 6 OH minus, here 10 OH minus ion, so 4 will be remaining. So now the remainder is 2 CrOH taken thrice plus IO3 minus plus 4 hydroxide ions gives rise to 2 chromate ions plus I minus plus 5 water molecules. Now you can see, is it balanced or not? See, 2 chromium atoms, 1 iodine, there also 1 iodine. Here see, 2 3s are 6 oxygens, 9 oxygens, 13 oxygens from a left side of the balanced reaction. 2 4s are 8, next 5, 8 plus 5, 13 oxygens balanced. Next one is 2 3s are 6 hydrogens, 4 hydrogens, 10. There see 10 hydrogens. Now it is a balanced chemical equation for the given reaction. This is about this reaction. If you have any doubts, please mention your doubts in comment box. If you feel useful and informative, please like, share and subscribe. We will meet in the next class. Bye. I love you.